Most applications need some large data presentation. Earlier, we only displayed static data with simple components like single text, buttons, etc. Today, we will dive into models and views in Qt, and I will show you how to display large data sets in your application. For example, views, tables, grids, and so on. The plan for today's video is to cover C++ models and the views in Qt Quick. By the end of the video, we will make this list application with all CRUD operations. So we can create, read, update, and delete data from the list. Model view is a class that contains the data and its structure. QML provides us with a couple of models like list model, table model, item selection model, etc. But most of the time you will create your own custom one in C++ using a QAbstractItemModel or a class derivative from it. So as you see, it's like quick presentation of from the Qt documentation how model and view work together. So model contains data inside it and structure, and the view is just for the rendering part. A view is a container for displaying collections of data. Qt Quick gives us a set of standard views like ListView, GridView, PassView, TableView, and TreeView. They're all customizable, and most of the time you will use one of those standard views because they really fulfill your needs and you can customize them in all kinds of ways. And as you see here on this graphical representation, view renders, model manages data and some business logic. Let's take a look at those views in the example project. So I just created a project, and let's create a new file, QML file. Let's name it list example, and it's QML file. Okay, I will paste the full example and explain what is happening here. And also we got to import Qt Quick controls. Okay, as you see here, we created list view and provided the model. So I told you before about list view. It's class the type representing data, and the model is just where we store the data inside it. The model contains list elements, where each one of them has properties. But in the case of models, we call them roles. And you will see why I mention it when we will jump to C++. We also provide a delegate here. There is just a template object that will be displayed for every list element inside a delegate. Use name here, name and email roles inside the text to display data, and they are matching with those roles here in the email. So to summarize, we have list view. There is the type to display list. Just we specify some height. Also, all those views have spacing, just spacing between elements, so they not like together. They have some gap between. And then we provide model. That is just a list model. Later we will create this in C++, our custom one, but for now I just want to show you an example. Inside list model, we just create items like in just list. Each one of them contains roles, name and email, and later in the delegate is just template for each one of elements in list that will be created for each of those list elements, and we use name and email roles to display some data. Okay, I repeated it twice because first time it may be hard to understand just right away. Okay, now we can go to main, and I will create a column layout because later we will make a grid, buttons, and so on. And also I have to import Qt Quick layouts because column layout is from the layouts module. Okay, we have our list with all the elements we provided. Let's run and see what we got. Here you see I have this list. And by the way, I didn't mention, but I think it's obvious, frame just adds border to our element, so you see the boundaries. I mean, you can replace it with item or whatever you like. Okay, we can customize it and add a header and a footer to this list. I also, okay, let me paste my code. So we can specify here header. It will be just a rectangle with width the same as our list, with the height 30, background color, and some text that it is contacts list, just as you saw at the beginning of the episode on my presentation. And let's also add footer. By the way, you can just select it and hit Ctrl-I, and it will fix all those tabs and spaces. Okay, I also pass footer positioning here, so the footer is always visible at the bottom, because you have different ways of presenting your of position your footer. You can read about it in documentation. It's just like it's overlay, or it's just at the end all the time, and like this, not some hard things. And I also provided z-value in the footer, and it can be different. Just make sure it is bigger than in delegate. In delegate I didn't specify nothing, so 10 is okay. Maybe I can pass 5, for example, but it doesn't matter, just so it lays on top of the last element, on top of the last delegate. There are also so many properties you can provide to your view. For example, you can add remove animation, selection, highlighting, etc. You can just go to documentation and see, because there is a lot of those properties, and I just won't be able to show you each and every one of them. And it's not hard to specify. Like here, I just pass a rectangle, and it will work right now, I hope. Let's see. Here, as you see, I have my rectangle with text, and on the bottom just my thinner rectangle, its footer, and 3 elements inside that I created. Okay, now let's explore GridView. GridView uses the same list model as here, but displays it in different way. So let's move out data to separate file. I will just create a new file with new QML and name it example dataset, just this list. And I'll extract from list example, pass it here, and fix spaces and tabs. Okay, and here I can just write example dataset, create a dataset type. Let's check if it works with our list. So we can continue with grid. Yes, as you see, it works. That's fine. Let's now, and in that way we can just avoid copying the same code over and over again. So let's create document for the grid and name it grid example. Okay, fine. And here, let me just copy and paste this code that I have. Example dataset. Fine. Here, just like before, I pass some width and height, then I pass model, the same list model with list elements, and then delegate. Here we use pretty much the same technique, but if the delegate doesn't have enough space horizontally, it goes on the next line. You're also able to specify cell width, height, and other unique for grid properties. But now I only show you a quick example of usage because I want to make this example with list just more complicated with C++ and to not spend your time on showing just the controls that you can test on your own simply. So let's put it in main. Also great example. And let's see how it looks like. And you see, as I said you before, when it doesn't have enough space, it goes on the next line. So here I just create text and the next text with the same rows as I done it before, and center it horizontally and put it in columns so they stay vertically aligned. So you basically saw how to create a model with some rows and display it in a list or grid in your QML. But we have done it in QML, but the problem is that QML is not that flexible. And when you probably will want to integrate your application with the database or other sources, and then you will have certain problems. Now I will show you how to create a model in C++. Firstly, we will make only the displaying part, so QML can just get data from it and display it in views, and then we will implement create, update, and delete functionality. Before we start, let's discuss two very important classes we will use to create a model: QAbstractItemModel and QAbstractListModel. QAbstractItemModel is an abstract class that defines the standard way components work with each other in model view architecture. If you don't remember from some basic C++ tutorials what is an abstract class, it is a class that can't be used directly. We must subclass an abstract class and create our new class by overriding some methods that are custom for each case. So we just have to override some methods because they don't really implement it. Okay, and QAbstractItemModel uses QModel_index for managing underlying data. QModel_index consists of row and column, so data is stored in a hierarchy of tables. But if you want a simple list, then it is just a table of rows or columns. So you just select your one dimension that you want to use, and it is not a problem. Every record inside the model can also have parent index. It is made for hierarchy. For example, views like File Explorer, like in File Explorer, where you have folder and parent, where you have folder as a parent and files as children. This class provides you so many methods you can implement, and they will be used by the view. Later, when we will implement, I will show you how many methods you can possibly override, and you really can do whatever you want with it. But you don't have to always use QAbstractItemModel and implement everything on your own. There are common usages of this class, for example, a list. Qt provides us with the QAbstractListModel that is also abstract and also has to be subclassed. But as the name suggests, it is already a non-hierarchical sequence of elements. QAbstractListModel is a subclass from QAbstractItemModel, so it is just an improved version for specific needs. And remember that QAbstractListModel is not the only class that can be used for more specific cases. You also have, for example, QAbstractTableModel, QFileSystemModel, QStringListModel, etc. So when you create your own application, open documentation and see what meets your needs the best. Okay, so let's create our list model and implement the create, read, update, and delete functionality in it. Firstly, add a QObject. Here, C++ class, go to QObject to your project, and let's name it contacts model. Let's create it, finish. And here we have it, CMake is loading, and I will right away change the class we're inheriting. Here I want to include QAbstractListModel, and this I will say in a second what we'll do with it. Let's change the class we're inheriting to QAbstractListModel, and also change it here in constructor. So you won't have any bugs later, and you don't forget about it. Okay, and I also right away want to make this class QML element, so we can instantiate it in QML. If you're not familiar with QML element macro and the C++ and QML integration, I strongly suggest you to watch my video about it, because I made a tremendous video that fully covers integration of C++ and QML. So in the source file we replace it, this class in the constructor, and now you can right click on the inherited class and go to refactor, inherit virtual functions of base class. Here you see the full list of methods we can override. The important thing is that you don't have to override every method. You need to do it only you need to do it with only the ones that you need for your purposes. So for example, if you want to only displaying, then override only displaying classes, and don't touch the others for updating. And it works, it's depending on what functionality you want to customly make in your list. To start off and display some data, we need to implement row count. It's already selected as some most basic one. Then data, so you can get some data from our model, and role names. Let's search for role names. Okay, I just wrote it here, role names. I can here it is on the bottom of QAbstractItemModel. Okay, and override add virtual. You can just leave it as the default, so it will be okay. We can remove comments because we'll later add new methods, and it is not necessary for now. Okay, so you see you have those definitions for your methods you have to implement, and okay, we have to store name and email. So let's also make a structure that will contain those fields, because I want to make a list with the same data as here. Okay, here I make a structure with the name and email with the QString class, and I also defined the enum here. And wait a second, and when we will implement data and role names, I will explain the point of using it and what is happening here, what Qt user role, why we should define it. Okay, we store a list. So internally in model, we should store some data. In our case, it's the list, so we can just make it like here with the structure contact. And I also have to include vector. Okay, and we can either use one of the containers that Qt provides us, or we can use STL, like I done it here. I will use STL because Qt containers are pretty much legacy. One of the worst parts of Qt containers is that they do not support move semantics. With HTML, we can be sure that it uses the most efficient ways of working with data, and it's already it always up to date with all updates and so on. So I prefer to use vector here. Okay, we started in a private member of our class. Now let's go to the source file, and we can implement everything. But first of all, I want to add some mock data. If you like, wait a second, let me copy, and here I will paste my mock data. Here I just give some data to my vector, some mock data that we will test our application with this data, and I just pass it in a constructor with those braces, so it will initialize structure. It's like one of the ways to construct structure in C++. Okay, and if you don't know what is QString literal and why am I using it, then I strongly suggest you to watch my video about it. I explain it well when to use QString literal, when other classes related to string, and so on. And in the real world scenario, you'll most likely create a separate class to work with database and call some method from it in a container. But here we can just hard code some data to have an example. So if you remember from presentation, you have this like model, and it's pointing also to the data. And this data can be like separated class where you call your API, database, or whatever. Okay, so now let's go and implement our method definition for the row count, for the data refactor, and then the definition, just to simplify what we are doing here. Okay, row count simply returns the number of elements the view has to display. I earlier said that the QModel index represents row and column. In this case, method receives a parent index. We can use it in case we have a nested structure and want to give the size of the current node. I also add the QDebug to output some text in console, and just so you see when this method is really called by Qt, by ListView. I also have to include it, I think. Include QDebug. Fine. I just write some data that notifying that row count is called, count is called, and return the size of my vector. Okay, role names. I will skip for now data. Okay, role names are an interesting one. We have to use a previously defined enum here. So let me copy and paste what is happening and explain you what is happening here. We have a hash table with the key of the enum and the value as the name of the property. Those names are going to be used inside QML. So like here. I use here name, email, and we define those strings with the roles. And here we specify it. So when you want to get a specific item in QML, you write a name of it. You write a name of property. But inside the C++ code, we can store it just as an integer, just as enum, to reduce the space that is used. The important thing to mention here is that Qt by default also have some roles. And I can show you by going to user role. Here you see we have some roles already. And because of that, our enum starts from user role. And then we continue this this list of enums because user role here is the last one. If we would normally leave it and start from 0, data won't be displayed because roles are conflicting with each other and just no data will be displayed. By the way, I don't use QString literal here because the qbyte array and it is similar to QString, but it is not the same thing. This structure is used to store both row bytes and traditional 8-bit strings. Okay, and then I just return this hash table with all roles and the name of roles defined, specified. Okay, we have a data method left for us. This last method to implement for displaying. This method receives an index of the record and the row that we should return. The row is representing a property of a structure. We store the current record. So let me just paste the implementation, and you will see what I mean. Because and also QVariant is used to store reference to values where you don't know what type is lying inside. When you want to get the value, you should call one of the converting methods that will return stored value. So I don't know if it will be visible here, but if I write like this, you see you have so many methods like toChar, today, time, double, and so on, so on. So you can just store a lot of primitive types inside QVariant. Because data method returns some properties. The property that Qt is calling, that wants to get from us. And inside method, we are checking if index is valid, or more specifically, if the index is not going out of boundaries of our list. The thing is that Qt displays view so that it fetches only needed ones, only needed records, and then deletes them from the memory when the user doesn't see them. I will later make the list bigger, and you will see what I mean by looking at the console output. And I mean, sometimes Qt can provide not a valid ID, so we have to check it here. And I return false if something is not right. Then I just qdebug something just so you see when Qt is calling our method, and then with the help of switch statement, I check what Qt asks for and return an according data. So here I just get the item that Qt calls us. I get row. I can also use column, but when you make your list, you just have to use one of it, either row or column. In my case, I will use row. and I return name if the role is name here. If role is email role, I return email. If none of them, then I just return false. Okay, and now let's create an instance of the model in main QML. It is quick and easy. And okay, so I can just write here contacts model unknown component, but if I okay, let's leave it as it is, because sometimes Qt okay, because I didn't import it. I have to import here when I use QML element. I also have to import this URI of my project and specify version. And now I will have it. I certainly will have it, okay? Let's move on quickly and also pass model in the list example, and we can also do it to the grid example just so you see that this class can be used in both cases. Let's delete from here model because we pass it from the main, and there is no sense to use it. And let's run application and check if it will finally work. Yes, as you see, it's just a problem of Qt Creator. And I made those QDebug prints, and as you see, if we run the application, first of all, everything works. Data is displayed with the help of C++ model. But let's quickly, maybe let's comment also grid, just to see what is written here, to not get anything duplicated. Okay, so take a look. As you see, row count is called multiple times by the engine. And it is okay because we only return the size, and it's like so quick operation. Role names is called only once, and Qt stores that hash table in memory. Then data is called, let's count 1, 2, 3, 4, 5, no, sorry, 3. It's either wait, why it is interesting because it calls it 5 times. Okay, let's Control F. Oh, okay, six times. I don't know. Maybe I'm just blind. And okay, so it is calling data method 6 times, and this is exact number of data properties we have, because there are 3 elements, and each have each of the element has 2 fields here, name and email, and we have 3 like instances of contact. So we get data called 6 times. Just so you see how it renders when you have so many items, let's copy records in the constructor so many times and see the output. I will just copy and paste so many times the same record. So let's see what we have in our console in application output. Okay, so first it loads some data, and now as I scroll, it will load more data, because now not all data is loaded. Loaded is only data that Qt needs to show. And now if I Okay, I have some bug with list, but it don't really matter. Probably I forgot to add some parameter. And if you see, new calls to row count and data are generated here as I scroll. As you see, Qt is calling data and frees memory from the first elements. So Qt just used that way of displaying. That Qt loads only records that should be displayed at this exact moment. We have our displaying functionality, so now it is time to create new items in a list. Earlier we needed to override the data method, this one. Let me also hide the output. Earlier we needed to override data method from the QAbstractItemModel to display the data. When it comes to insertion, QAbstract list QAbstractItemModel has base methods, but you don't really have to override them. So you have this insert rows and insert columns, but it is not like required to override them. You can create just a QInvocable method that receives whatever parameter you want and returns whatever value you want, but to get data updated in the GUI, you must call two specific functions from the QAbstractItemModel. Those are called begin insert rows and end insert rows. I will show you now what are they and how to use them. And you should call them at the beginning and the end of insertion. And the same applies to columns. Because here you also have insert columns. But in the list view, it only makes sense to change the number of rows. Okay, so even though I don't have to override a base method, I will do it, and I will also create my own method that will just call a base one with certain parameters to make the job easier in QML. So I just want to show you all ways to do it. Let's move it to all our methods, delete these comments. So here we have insert rows, and I will also create method that will be called from, that will be like manually called from QML. I will make this QInvocable. If you don't know what is QInvocable, go to the C++ with QML integration video, and let's implement them. So refactor, a definition as always. Here, this, sorry, here the same. Okay. Insert rows method returns a boolean value. And it returns it depending on the success of adding a new item. So if something is not right, something is failed, then false. It's everything is okay, then true, simply. And let me paste my implementation. Here we have it. Okay. On the first line, I'm making sure that the row and count are not negative. So here it's if it is less than 0 or count is less than 0, I return false, and everywhere I use OR. Also, I make sure that the row where I have to insert new items is not bigger than vector size. I call here row count, but you could also call just items size. Doesn't really matter. And I check it because otherwise I can get some kind of gap in the data. So I can have like a list. Let's show it just with digits. Like this list, and I should insert from like to 6 index, 6 row, and count 2. So I will have, okay, it is index 3, so I'll have like this gap. and to avoid it, I check it and return false if something like this is passed. After validation, I call begin insert rows method, where we have that method from QAbstractItemModel, as you see here, and I pass a parent index that always will be empty in our case because we don't have any sub-element system. Then row index where I start, and the row index where I finish. And here I make some kind of calculations. So I give row plus count because there is count of elements we will insert, because method is called insert rows, like many, and -1 because the list has zero-based indexing, and it also takes the last element into account. The actual insertion is probably the most understandable part of everything here for you, because I just make loop and insert a new empty contact instances to the vector. So here just call begin plus index where I want to insert. Just call in a standard method from STL. And after all insertions, I call end insert rows to notify Qt that view can be changed. So when we call it, the visual representation will be changed in some way, and I like update it. Okay, so here in the next method, append empty row is just adding a new item to the end using a previously defined method. I want to use all the power of insert rows and insert a lot of items at once, but I wanted to show you how to implement it. Yes, maybe you want it. Okay, and here I call row counts, and every time I provide some parameters. Maybe we can just make here default value to make our job easier and to not call it every time. Okay, fine. Now let's add an add button in our QML. It will just call this append empty row method on click, nothing more. So let's go to the main. We can delete this grid and add button. Here also import Qt quick controls, because that is where button is laying. And on clicked, we just call context data append empty row. Let's start. Let's run and check if it works fine. Okay, let's add something, and we have our empty contact. We can add more and more. Okay, great. And now it comes to the most, I think, interesting part, updating data. Let's go to our class. So parent class QAbstractItemModel already has a method for changing data. We just have to override it. So it's called setData here. Let's override, okay. And let's move it to our methods and add definition in source file. Similarly to the insertion, we have to return Boolean value that shows if an operation was successful. Okay, the method receives an index of the element you have to modify. In our case, we will only use a row, even though, as you already know, QModel list contains row and column. A value with the type QVariant that will be converted to a specific type depending on the role. That is a third parameter. So Here you have my implementation. So firstly, I validate the index and create a reference to the item that should be modified. With the help of switch statement, I check what role should be modified, and if it is just some random int in the default case, then I just return false. As you see, I call value to string here and there, but the Q variant can, as I showed you before, Q variant can be converted to all kinds of primitive data types. So you can store in your structures integers, all kinds of numbers, dates, and so on, so on. Maybe some arrays. Okay, and finally, I not return anything like in create, like in data, sorry, like in data, because here I just return data that is requested. Here I modify data, then break this switch statement, and after that, finally, to notify Qt about data modification, I emit the data changed signal with the current index vendor. Here I was indexing index because if you take a look inside, it comes from the QAbstractItemModel, and it also can work for the tables. So we have a top left and bottom right index we should pass, and the rows that was changed. In our case, only one row was changed, so I just create this QList in this way with the initialization list, initializer list. Okay, and the QML part will be a little bit harder than before. It's not just adding a button now, because I want to replace the text item with the text field when a user clicks on a text, so he can edit it. So you will see now what I mean by that. It's just I found it like cool functionality. So let's add. Okay, for now, .add. Take a look here, because I will do it inside my delegate, and I will have to separate the text into three parts. First, it's like part with the name text that will be sometimes replaced with text field, and sometimes it's just text. Then this column sign, and then email. So it will be such a mess if I make everything in one document. So let me make and this elements with name and email will be the same, pretty much the same implementation. So to not repeat the code, let me create a new document for it. And let's name it editable text. Here, let me pass some starting things. Here, I specify a required property, which is a field. The field that the item should work with. I add the text and text field that is coming from controls, and I put everything in row layout so it lays horizontally. Okay, and here I will switch visibility of those two items depending on if user clicks on it or no, if it's empty or not. And okay, the initial visibility is defined by whatever field is empty or no. So if it is empty, then I show text field and user have to write something inside. If it have something inside, then user see text with this field. Okay. And to give the ability to click and edit, let's add a mouse over and the slot in the text field. So let me show you how I done it. So here I just provide mouse area, and when I click it, I fill it with my name text, of course. And when I click on it, then name text becomes invisible, and edit field becomes visible, so user can write something, modify something. And when the user already modified something and want to like change it inside our model, there is that event called on editing finished, so either user presenter or something. Then I assign this text from the text field to the field and change visibility one more time. And now when the field is empty, the text field is always shown, and set data method that we implemented earlier here, set data, will be called when is being called when I assign a field to the text input. So because here field I won't pass just some string, I will just pass this role from the model. Let me show you. Let's go to the list example, and you will see what I mean by that. So here I kind of rewrite this delegate, and okay, and I have to import Qt quick layouts. Maybe yes. Okay, so here I changed this delegate, rewrite it slightly. So here I have row layout, so everything lays horizontally. For now, it not really makes sense, but later I will add deletion functionality and I will add button here. And inside I make another row layout for everything also lays horizontally. And I make two editable text items. First with field name and second with email. And between them I make that column. And let's run it and see how it works. Let's add, and you see I can add something. If a field is empty, then it won't be changed to the just text because of where editable text, because of this if statement. But if I write something, don't know, email, doesn't matter, and press enter, then I have it, and I can modify it, change it. So and here also I can modify, change it. I can here modify, just you see how it works. I mean, I can modify and change the values. I can click, and it is changed. Okay, fine. The way of deleting data is pretty similar to insertion, and we also can but don't have to define the remove rows method and call specific methods before and after the deletion. So it is pretty similar to insertion. Let's quickly do that and finish with our CRUD functionality. So go ahead, let's add implementation for remove rows. Move it a little bit higher. And I'll also, just as with the insertion, I'll add my method that will be just easier way to use this one. And parameters are similar to the, the same as in insert rows method. So it is obvious that we just have to remove the count items starting from the row index. Let's add implementation as a definition and implement those functions. Yes, edit those methods. So here I don't know if you see, because it's pretty long line. Make it like this. Okay. So the implementation is pretty similar to the insertion, but like as previous, I validate indexes that were given to me, so nothing will crash with my STL when I call this erase method. And just accept, and everything is the same except the thing that I call begin remove rows and end remove rows with the same indexes, and I call erase instead of making some loop, because it still provides us a method where we can just remove from this to this, where we can provide the starting point and end point, and we can erase everything from a vector. And inside the remove add, I can just write like this. I mean, I just call this remove rows method, starting with row that is provided to us, that I will provide from a QML, only one element, and empty QModel index, because we don't have any parents in our case. Let's go to the list example. And here inside the delegate, as I said you before, after row layout, I will add a button that will just call the remove add method and remove corresponding record. So here, except this stuff that you know, like passing text as minus, here I get this list because I have ID list in ListView. Then I go to the model that is provided from main. Here we provide model, and then call remove add method, providing model row. Model row is just model. In our case, it's just the record. It is just a thing that is available to the delegate. We can get the record we're working with right now with the help of model, and I get row from it. The same, I can also get column if I want. So okay, let's run and see if it works. And we can remove, add, edit something, create whatever you want. Remove, add, remove. Maybe let's add many items, and just this way. And that is how we done CRUD operations in Qt, in Qt Quick with C++ model. I hope you enjoyed, I hope you, first of all, learned something from this episode, because it was pretty long. I'm pretty tired right now, and also feel free to write your feedback in the comments, and see you later.